Welcome to video 7. Before going any further in this video, make sure that you've gone back and done the first practice section for 1-8. Make sure that's complete. Go ahead and check your answers. Make sure you have a good grasp on that, and then go ahead and come back and we'll resume this video. For those of you that have already done that, we'll go ahead and take a look at graphing inequalities. What this is going to do is this is going to combine the functions from the beginning of this lesson, graphing on the coordinate plane, being able to graph a line, and it's going to combine it with 1-6s when we're graphing inequalities, and we had to worry about shading and whether things were open or closed. So the only thing different is rather than just one single line being the ordered pairs true, we're going to have a whole region of ordered pairs. And the way that we're going to show this, and that you're really going to be able to tell inequalities apart from equations, is that we're going to do something called shading, just like we did when we were doing the inequalities with a single variable. Alright, we gave you a helpful little chart when we were doing inequalities. We're going to have another helpful chart here when you're taking an inequality with two variables. That's the reason we're moving from just one number line to two, is these inequalities are going to have both an x and a y variable. So, if we are looking at a less than, we are going to draw a dotted line, and we are going to shade below the line. If we have a less than or equal to, that equal to means that that line can be a solution, so we're going to do a solid line. This matches up with our open circle and our closed circle when we are doing these on the number line. A less than or equal to is also going to be shaded below. A greater than, since it doesn't have the line, is going to be a dotted line, but we're going to shade this one above. A greater than or equal to has that line underneath it, so it's going to be a solid line, and we're going to still shade above. So we're asked to graph the following inequality on the coordinate plane. We're going to start by doing the exact same process that we did when we were just drawing an equation. We still want to find our y-intercept. In this case, it's going to be -1. So we're just going to put a dot at -1. Next thing, we still want to find our slope. Our slope is 2. So we're going to go up 2 and to the right 1. Up 2 and to the right 1. Up 2 and to the right 1. So first couple steps, exactly the same. What we need to look at now is what kind of line we're going to draw. We don't want to just go ahead and draw a solid line. We need to think about what this is going to be. If I look at my symbol, it's going to be a greater than or an equal to sign. So if we go back to that chart, that means we're going to have a solid line. So we're going to draw a solid line. And the reason why is because we have that equal to portion. We have the line underneath it. That means that any point on this can be a solution. So I'm going to go ahead and draw my solid line. I still want to make sure I have arrows at the end of both sides. And we have our solid line. If this would have been a less than symbol, then if this would have just been a strict greater than symbol, and we wouldn't have had the line underneath it, we would have been dashed, and answers on this line wouldn't have actually been part of our solution. Alright, we next need to look at where we shade. If we look at our symbol as greater than, that tells us that we shade above, because we have a greater than or equal to. It's the greater than portion that's going to give us the hint there. So we're going to shade everything above the line. If you were looking at this like it was a hill, you want to shade everything that goes above the hill, above the ground. And it doesn't have to be perfect. You just want to make sure that you can get the gist and the idea of this. A lot of people like using colored pencils for these so that they can see where they're shading. You're more than welcome to. And what this is going to do is this is going to represent all the possible solutions. So any number that we pick that's in this shaded region is going to make our inequality true. So when we're asked for two possible solutions, we can pick any ordered pairs over here. Or since this is a solid line, we can take any ordered pair on the actual solid line. So just picking a couple points, if I went to -2, 0, that would be in my shaded region right here. Now, since this is a solid line, I could also pick any point on this line. If it was a dashed, it wouldn't work, but since it's solid, we can go ahead and pick from there. And so, for example, here, I could have 1, 1, and that would work. Now, if we were asked to give solutions that don't work, we would pick anything outside here that's not shaded. So, for example, we could do 5, 0. And I'm going to scroll down just a little bit so that we can get on there. Or we could do anything else in this region. Let's say, for example, once it stops moving, 6, negative 6. Anything that is in this region that's not shaded would be something that works. Alright, let's look at one more example. Sometimes, just like when we were doing the equations, you might get one that's not in slope-intercept form. We need to put it in slope-intercept form before we can graph it. So we have 3x plus 2y is less than 8. We need to get that y by itself. So to do that, we need to move the 3x to the other side. So we're subtracting 3x from both sides. So we would have 2y is less than negative 3x plus 8. And then we would divide everything by 2. Now our rules from inequality still apply. If we were to have divided this by a negative 2 instead of a positive 2, if we divide or multiply by a negative number, you would need to flip that sign. We divide by a positive 2, so that sign is going to stay the same. So we're going to graph the same way. Our y-intercept is going to be 4. Our slope this time is negative 3 over 2, so we're going to go down 1, 2, 3, and to the right 2. 1, 2, 3, and to the right 2. 1, 2, 3, and to the right 2. And now we need to look at what kind of line we're going to draw. If we look this time, we have a less than symbol. We do not have the line, so that means this is going to be a dashed line, a dotted line. Instead of doing something that was solid, we're going to need to leave some gaps in this, and it will be a dashed line like this. That means the answers on this line are not part of your solution set because it's not equal to. And our reason why we don't have the equal to part, it is just a less than symbol. Now for where we shade, this is less than, so we shade below. Alright, if we were looking at this like a hill, this would be above ground here, this would be below ground here, so we're going to shade in this region here. If we are giving two possible solutions, this time since it's a dashed line, we can only pick from the shaded region, we can't pick from the line. So for example, we could have 0, 0 right there at the origin, or we could have, let's say, negative 1, 1, and those would both be possible solutions. As far as no solutions go, we could pick anything over here that's not shaded. So for example, 5, 0. Or since this is a dashed line, our answers on here are not part of the solution, so we could use 0, 4 since it's on the line, but it's on a shaded line. Alright, you guys do the U-try problem, and we'll take a look at some word problems in our last video for 1-8, video 8. See you guys then.